Good morning students. Welcome back to Sunain Sir's online classes. In this video, I am going to explain you Human Eye and Colorful World chapter part 3. Under part 3, the topics which we are going to discuss are dispersion of light, lab activity to find refractive index of prism, and activities to observe dispersion of light, or they are also called as artificial rainbow activities. Now let us go into the topic one by one. First, dispersion of light. The process of splitting up of white light into 7 colors, that is Cbse, is called dispersion. So this can be done by passing a white light through prism. Here in the prism, if you focus white light on the prism will divide this white light into 7 colors, that is nothing but Cbse. This is called Cbse spectrum. Now, why light separates into 7 colors when it passes through prism? Now, what is the reason for dispersion? This is what we are going to see. Reason for dispersion of light. We know that speed of light is constant for all colors when it moves in vacuum. But when light passes through any other medium other than vacuum, speed of light is different for different colors. Speed of light will be constant for all colors when it moves in vacuum, whereas it will be different for different colors when it moves in any medium other than vacuum. So when light passes through prism, since each color is having different wavelength, each color will undergo different deviation. So here we know that speed of light is given by V is equal to lambda into f, that is wavelength into frequency. Since speed of light is different for different colors in any medium, then V changes. When V changes, then lambda, that is wavelength, also changes. It means wavelength of the light will be different for different colors. It means for red, since wavelength is more, it is 700 nanometers. For red, velocity of the light will be more, whereas velocity of violet color will be less because its wavelength is only 400 nanometers. We know that wavelength of the Cbse spectrum is 400 to 700 nanometers. So when wavelength is more, remember that refractive index will be less. So when wavelength is more, refractive index will be less, and wavelength is inversely proportional to refractive index. And deviation of light through prism is given by n is equal to sine of a plus d by 2 by sine of a by 2. It means if angle of deviation will be more when refractive index is more, and angle of deviation will be less when refractive index is less, and in turn this refractive index depends on wavelength. So finally what I would like to say is, so wavelength, when wavelength is more, refractive index will be less, it means angle of deviation will be less. When wavelength is low, refractive index will be high and angle of deviation will be high. So this is the relation between wavelength, refractive index and angle of deviation. So for red color, angle of deviation will be low, and for violet color, angle of deviation will be high. So exactly this is the reason for dispersion of light. When light passes through prism, in this light there will be 7 colors. Out of these 7 colors, wavelength for red is high, it means refractive index for red will be low, it means angle of deviation for red will be low. That is why on the top red color will be seen, whereas wavelength of violet will be low and refractive index of violet will be high, it means angle of deviation of violet will be high. That is why violet can be seen at the bottom. So violet color will undergo, it will suffer more deviation and it will bend more, whereas red color will suffer less deviation and it will bend less. So in this way all the colors will split up into in this way white light will split up into 7 colors because of their different angle of deviations. So as red light has largest wavelength, it will have smallest refractive index, therefore it will undergo low deviation, whereas similarly white light will undergo high deviation because of low wavelength and high refractive index. So this is the reason for separation of white light into 7 colors. So finally conclusion is dispersion will takes place because of different angle of deviations for different colors. Simply, in order to say simply, angle of deviation will be different for different colors. Angle of deviation will be low for red color and angle of deviation will be high for violet color. So it will undergo dispersion. In this picture you can see white light is sent through prism. So after passing through prism, this violet is divided into 7 colors, and you should write VGR from the bottom, that is violet should be at the bottom and red should be at the top. In this way you need to write VGR. Some of the people will write VGR from the top, but this is not correct way to write, because violet color will suffer more deviation, that is why it should be at the bottom, and red color will suffer less deviation, that is why it should be at the top. Now let us see lab activity to find refractive index of prism. So this is very important question regarding 8 marks according to new pattern of public examinations, and the diagram present in this lab activity is also very important regarding diagram session in public examinations. So first let us see what is prism. Prism is a transparent medium which contains two plane refracting surfaces at some angle. This is one refracting surface, plane refracting surface. Back side there will be another plane refracting surfaces. These two refracting surfaces are put at some angle, they are arranged at some angle. It is nothing but a prism. When you arrange these two surfaces at some angle, then it is called prism, and angle between these two refracting surfaces is called angle of prism A. It is called angle of prism A. So before going into the actual lab activity, first let us see the terminology in prism. In prism there are two refracting surfaces. This is one of the refracting surface and this is another refracting surface. This is side, I am calling this side as AB, this side as AC. Now the light ray whichever incident on first surface, this is first surface, the light ray whichever incident on first surface is called as incident ray, and if you draw perpendicular to the side AB, this is normal, it will become normal. Now the angle between incident ray and normal is called angle of incidence. This is angle of incidence I. And after undergoing refraction, when light ray is incident on the first surface, it will undergo refraction. It will move straight in this way parallel to the base, and then this light ray will come out from the second surface in this way. So the light ray whichever it is coming from the second surface is called emergent ray. The light ray whichever it is coming from the second surface, it means the light ray which is coming out of the prism is called emergent ray, and angle between emergent ray and normal, this is normal to the second surface. Angle between emergent ray and normal is called as angle of emergence. And now finally we need to see what is angle of deviation. So angle of deviation is nothing but angle between incident ray. If you extend incident ray, this is incident ray. So angle of deviation is very important. Please see once again. If you extend incident ray, this is incident ray and this is emergent ray. And if you extend this backwards, emergent ray, the angle between incident ray and emergent ray is nothing but angle of deviation D. This is called as angle of deviation because The name itself says that incident ray, if there is no prism, it would have gone straight like this, but because of presence of prism here, instead of going straight in this way, this incident ray is coming out of the prism in this way. Since it is deviating from its path from here to here, it is called as angle of deviation. Angle of deviation D. Angle between incident ray and emergent ray is nothing but angle of deviation. I request you to practice this diagram as it is very important regarding diagrams. Now let us go into the actual lab activity. So here the aim is finding refractive index of prism. Apparatus: prism, white chart, pencil, scale, pins, protractor. Now procedure is, first you need to take a prism and place it on a white chart. Using pencil, draw border throughout the prism. First what you need to do is take a prism, first take a wooden plank and then take a white chart and then place a prism on this white chart. After placing on white chart, by using pencil, draw borders throughout the prism. Throughout the prism, draw borders and then remove the prism. When you remove the prism, the shape which you will get is triangle. Name the vertices as PQR. Name the vertices as PQR. So you will get a triangle. Name the vertices as PQR and now draw normal to the sides PQ and PR. Draw normal to the sides PQ and PR. Now what you need to do is, by using protractor, draw a line at an angle 30 degrees to the normal of side PQ. To this side PQ, draw a line at an angle 30 degrees with respect to the normal. So this line will act as incident ray and this angle 30 degrees is nothing but angle of incidence. Now what you need to do is take two small pins and place them on this incident ray. Take two small pins and place them on the incident ray. Now replace the prism in its original position. Replace the prism in its original position. Now try to observe these pins. Try to observe these pins from the other side. Wherever you see the image of the pins here, mark a point over there. Wherever you see the image of the pins, mark a point over there. Now by using scale, join these 2 points with a straight line. Join these 2 points with a straight line and measure the angle between this normal and this straight line. This straight line will act as emergent ray. Measure the angle between normal and emergent ray. This angle will be equal to angle of emergence, and extend incident ray and emergent ray, and if you measure the angle between incident ray and emergent ray, you will get angle of deviation. Now let us see once again. Take a prism and place it on white chart. Using pencil, draw a border throughout the prism. Now remove the prism. You will get the shape of a rectangle. Name the vertices as P, Q and R. Now measure the angle between sides PQ and PR. It gives angle of prism. Draw perpendiculars to sides PQ and PR. By using protractor, draw a line at an angle 30 degrees with respect to normal to the side PQ. This line indicates incident ray. Now place 2 pins on the incident ray. Replace the prism in its original position and place 2 pins on this incident ray. Replace the prism in its original position and try to observe these pins from the other side of the prism. Wherever you see the image of these prisms, mark a point over there and join these 2 points with a straight line. This straight line will act as emergent ray. If you measure the angle between emergent ray and normal, it will give you angle of emergence. Measure the angle between normal and emergent ray. This angle represents emergent angle. Extend incident ray and emergent ray backwards till they meet. Measure the angle between incident ray and emergent ray, which gives angle of deviation. Note down all the angles in a table as shown below. As shown here, measure the angle of prism, angle of deviation, and calculate refractive index by using formula n is equal to sine of a plus d by 2 divided by sine a by 2. By using this formula, find refractive index of the prism as we have a and d. After finding refractive index of the prism, repeat the same experiment with different values of angle of incidence and angle of deviation. In all the cases, find refractive index and you will get refractive index of the prism. Now let us move on to activities to observe dispersion of light. In that, these activities are also called as activities to form artificial rainbow. That is, we know that yesterday's class we have seen how natural rainbow will be formed. Now in this video we are going to see how to form artificial rainbow. First activity 1. First activity is take a prism and place it on the table. Take a wooden plank and make a small hole in it. In this way, take a wooden plank and make a small hole in the wooden plank, and in front of the wooden plank place the prism, and on the other side of the wooden plank place a white light source, and on the other side of the prism place a white screen. Now switch on the white light source. This white light source will fall on the wooden plank and it will pass through small hole. It will pass through the small hole of wooden plank and it will fall on the prism. This white light, when it falls on the prism, it will undergo dispersion, and this dispersion of the light, Cbse or spectrum, we can observe on the white screen. On the other side of the plank, place the prism such that white light falls on the prism through a narrow hole. Beside the prism, place a white screen where you can observe 7 colors Cbse. In order to observe bright Cbse or spectrum, you need to perform this activity in a dark room. Another activity to observe dispersion of light, that is, take a metal tray and fill it with water. Place mirror in water such that it makes some angle with the water surface. Now focus white light on the mirror through water. Here in this image, as you can see, take a mirror and first take a metal tray and fill it with water, and then take a mirror and place it in the water at some angle. After that, focus white light on the mirror through water, and if you place a white screen above the mirror, you can observe Cbse or spectrum. Now place a white screen above the mirror where you can observe a Cbse or spectrum. In order to observe bright spectrum, perform this activity in a dark room. Next, artificial rainbow. This activity is famously called as artificial rainbow activity. That is, in this activity, select a white colored wall on which sun rays falls. Stand in front of the wall such that sun rays fall on your back. Now hold a water tube through which water is flowing and obstruct the flow by placing your finger between the water tube. Water comes out as a shower through small gaps between your finger and pipe. Now when sunlight falls on this shower, you can observe a Cbse or spectrum. This is very similar to the natural rainbow. In natural rainbow also, we know that rainfall happens in the form of small drops. When sunlight falls on these small raindrops, it will undergo dispersion. Similarly here also, when we obstruct the flow by placing finger in the tube, water comes out as a shower through small gaps between finger and pipe. When sunlight falls on this shower, you can observe Cbse or spectrum. Thank you for watching the video.